Have you ever wondered why we can't measure a coastline exactly, or why dropping needles on a floor can reveal the value of pi? Today we're diving into a world where infinite complexity meets stunning simplicity. We'll explore how everything, from the numbers in your calculator to the thoughts in your head, is an approximation. And yet, from this sea of uncertainty, we'll discover how perfect mathematical constants emerge. Let's start with a seemingly simple question. What's the exact value of pi? You might say 3.14159, but those dots are doing a lot of heavy lifting. Take your computer, for instance. It doesn't store exact numbers. It uses something called floating point arithmetic, which is just a fancy way of saying really good approximation. Even when you think you're dealing with precise values, you're actually working with approximations. Let's take this idea of approximation and apply it to something more tangible, like measuring a coastline. Sounds simple, right? The more precisely you try to measure a coastline, accounting for every tiny inlet and outcropping, the longer it gets. In fact, if you could measure it down to the atomic level, the length would approach infinity. And yet we can still easily measure the area of the land. How can something have an infinite perimeter but a finite area? But here's where things get really weird. What if I told you that by randomly dropping needles on a floor, you could calculate the value of pi? Here's how it works. Drop a bunch of needles onto a floor with parallel lines. Count how many needles cross a line. Do this enough times, and the ratio of needles that cross a line to the total number of needles will approach 2p. It's as if pi is hiding in the very fabric of randomness itself. But how can chaos lead to such precise results? So what does all this mean? From the tiniest scales of quantum mechanics to the vast complexities of human thought, everything is an approximation. Reality isn't made of crisp lines and exact values. It's a blur of probabilities and potentials. And yet, from this sea of uncertainty emerge constants like pi, perfect and unchanging. It's a reminder that even in a universe of infinite complexity, there's an underlying harmony waiting to be discovered. As we continue to explore and measure our world, we're not just approximating reality, we're revealing its hidden elegance. And isn't that the most beautiful approximation of all? As we've seen, from the randomness of Buffon's needle to the enigmatic emergence of pi, our universe is a tapestry woven from uncertainty, yet threaded with astonishing precision. If you've enjoyed this exploration into the harmony hidden within chaos, do give us a like. Subscribe for more journeys into the unknown and share your thoughts or questions in the comments below. Your curiosity helps us dive even deeper. And if you're hungry for more, our next chapter will unravel the secrets of the Monty Hall problem, a puzzle where probability defies intuition and randomness takes center stage. Will you switch doors or stick with your first choice? This video was brought to life by our dedicated team, scripting by Your Name, visuals by Visual Artist, and sound design by Sound Designer. Special thanks to our community of curious minds. Before you go, a fun fact. Did you know that if you search long enough within the digits of pi, you'll eventually find any sequence you can imagine? Your birth date, a poem, even this very script, hidden somewhere in the infinite randomness. Stay curious, and until next time, keep seeking the harmony in chaos.